Welcome to Big Data Analytics Technique and Tools. Module 3, Big Data and the Business Case. Big data is quickly becoming more than just a buzzword. A plethora of organizations have made significant investments in the technology that surrounds big data and are currently starting to leverage the content within to find real value. Even so, there is still a great deal of confusion about big data. Similar to what many information technology managers have experienced in the past with disruptive technologies. Big data is disruptive in the way that it changes how business intelligence is used in a business. And that is a scary proposition for many senior executives. Perhaps some of the strife comes from the term big data itself. Non-technical people may think of big data literally as something associated with big problems and big costs. Presenting big data as big analytics instead may be the way to win over apprehensive decision makers while building a business case for the staff, technology, and results that big data relies upon. Realizing the value. A number of industries, including healthcare, the public sector, retail, and manufacturing, can obviously benefit from analyzing the rapidly growing mounds of data. Collecting and analyzing transactional data gives organizations more insight into their customers' preferences, so the data can then be used as a basis for the creation of products and services. This allows the organizations to remedy emerging problems in a timely and more competitive manner. The use of big data analytics is thus becoming a key foundation for competition and growth for individual firms, and it will most likely underpin new waves of productivity, growth, and consumer surplus. The case for big data. These elements are knowledge discovery, actionable information, short-term and long-term benefits, the resolution of pain points, and several others that are aligned with making a business process better by providing insight. Building an effective business case for a big data project involves identifying several key elements that can be tied directly to a business process and are easy to understand as well as quantify. Big data is a disruptive element when introduced into an enterprise, and this disruption includes issues of scale, storage, data center design. The disruption normally involves cost associated with hardware, software, staff, and support, all of which affect the bottom line. That means that return on investment or ROI and total cost of ownership or TCO are key elements of a big data business plan. The trick is to accelerate ROI while reducing TCO. The simplest way to do this is to associate a big data business plan with other IT projects driven by business needs. Businesses are actually investing in storage technologies and improved processing to meet other business goals such as compliance, data archiving, cloud initiatives, and continuity planning. These initiatives can provide the foundation for a big data project, thanks to the two primary needs of big data: storage and processing. Lately, the natural growth of business IT solutions has been focused on processes that take on a distributed nature in which storage and applications are spread out over multiple systems and locations. This also proves to be a natural companion to big data, further helping to lay the foundation for big analytics. solid business case for big data analytics, the complete background of the project, benefit analysis, options, scope and costs, risk analysis. Building a business case involves using scenarios and providing supporting information. An extensive supply of example exists, with several draft business cases, case scenarios, and other collateral, all courtesy of the major vendors involved with big data solutions. Notable vendors with massive amounts of collateral include IBM, Oracle, and HP. The complete background of the project. This includes the drivers of the project, how others are using big data, what business processes big data will align with, and the overall goal of implementing the project. The project background will always be at the beginning of your proposal, right after the introduction or executive summary. This is the part of the proposal where you can explain exactly why your project should take place in your community and what the problem is you aim to solve. Benefits analysis. Align the benefits of the project with the needs of a business process or requirement. It is often difficult to quantify the benefits of big data as static and tangible. Big data analytics is all about the interpretation of data and the visualization of patterns, which amounts to a subjective analysis, highly dependent on humans to translate the results. An example of that would be to identify a business goal, such as 5% annual growth, and then show how big data analytics can help to achieve that goal. Options. There are several paths to take the destination of big data, ranging from in-house big iron solutions to hosted offerings in the cloud to a hybrid of the two. It is important to research these options and identify how each may work for achieving big data analytics, as well as the pros and cons of each. Preferences and benefits should also be highlighted, allowing a financial decision to be tied to a technological decision. Scope and costs. Scope is more of a management issue than a physical deployment issue. It all comes down to how the implementation scope affects the resources, especially personnel and staff. Scope questions should identify the who and the when of the project, in which personnel hours and technical expertise are defined, as well as the training and ancillary elements. Costs should also be associated with staffing and training issues, which helps to create the big picture for TCO calculations and provides the basis for accurate ROI calculations. Risk analysis. Calculating risk can be a complex endeavor. Big data analytics is truly a business process that provides business intelligence. Risk calculations can include the cost of doing nothing compared to the benefits delivered by the technology. Other risks to consider are security implications, CPU overhead, compatibility and integration issues, and disruption of business processes. All of these elements can be considered risks with a large-scale project and should be accounted for to build a solid business case. Of course, the most critical theme of a business case is ROI, the return or benefit that an organization is likely to receive in relation to the cost of the project is a ratio that can change as more research is done and information is gathered while building a business case. The rise of big data options. Teradata, IBM, HP, Oracle, and many other companies have been offering terabyte-scale data warehouses for more than a decade. For big data analytics, data must be processed in parallel across multiple servers. In addition to having exhaustively maintained transactional data from databases and carefully culled data residing in data warehouses, organizations are reaping untold amounts of logged data from servers and forms of machine-generated data, customer comments from internal and external social networks, and other sources of loose, unstructured data. Such datasets are growing at an exponential rate, thanks to Moore's Law. Moore's Law states that the number of transistors that can be placed on a processor wafer doubles approximately every 18 months. Each new generation of processors is twice as powerful as its most recent predecessor. Similarly, the power of new servers also doubles every 18 months, which means their activities will generate correspondingly larger datasets. The big data approach represents a major shift in how data are handled. In the past, carefully culled data were piped through the network to a data warehouse, where they would be further examined. However, as the volume of data increases, the network becomes a bottleneck. That is the kind of situation in which a distributed platform such as HADOOP comes into play. Distributed systems allow the analysis to occur where the data reside. Traditional data systems are not able to handle big data effectively, either because those systems are not designed to handle the variety of today's data, which tend to have much less structure, or because the data systems cannot scale quickly and affordably. Big data analytics works very differently from traditional business intelligence, which normally relies on a clean subset of user data placed in a data warehouse to be queried in a limited number of predetermined ways. Big data takes a very different approach in which all of the data an organization generates are gathered and interacted with. That allows administrators and analysts to worry about how to use the data later. In that sense, big data solutions prove to be more scalable than traditional databases and data warehouses. HADOOP. It is an open source software framework for storing data and running applications on clusters of commodity hardware. HADOOP provides massive storage for any kind of data, enormous processing power, and the ability to handle virtually limitless concurrent tasks or jobs. Why is HADOOP important? So we have 6 different reasons. First, we have the ability to store and process huge amounts of any kind of data quickly. With data volumes and varieties constantly increasing, especially from social media and the Internet of Things, that's a key consideration. Second, computing power. HADOOP's distributed computing model processes big data fast. The more computing nodes you use, the more processing power you have. Third, fault tolerance. Data and application processing are protected against hardware failure. If a node goes down, jobs are automatically redirected to other nodes to make sure the distributed computing does not fail. Multiple copies of all data are stored automatically. Fourth, flexibility. Unlike traditional relational databases, you don't have to pre-process data before storing it. You can store as much data as you want and decide how to use it later. That includes unstructured data like text, images, and videos. Fifth, low cost. The open source framework is free and uses commodity hardware to store large quantities of data. Sixth, scalability. You can easily grow your system to handle more data simply by adding nodes. Little administration is required.